Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And I'm Isabella. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and social media.
All right, thank you for taking care of that, Isabella. Now, Devin has to go through all of that. And
I mean, it's right there, right? It's run right down, wonderfully laid out.
easy to do. So where do you go to school?
I go to Ronald Reagan.
And what grade are you in?
4th.
How is 4th grade?
It is going very well.
It's very good. Well, I'm glad to hear that. Is there anything that you have had difficulty with as far as math so far in 4th grade?
I don't think so, because I'm getting help from my parents.
Oh, good. Well, that's the best place to get help, right? Because that way you've got people right there to help you out and things like that. So there's nothing that is like throwing you a curve or you think you need a little bit of extra help with?
No, I don't.
What kinds of things have you been doing in math in 4th grade?
I've been doing long division.
And you feel pretty good with that? You're going to be able to show us a little bit of that later on?
Yep.
Oh, good. You know what? We're going to do a little division right now, but it's going to be in the fraction form. Have you ever done that yet?
No.
Let's take a look at today's social media problem of the day, all right? So it's going to be right up here. So it says, what fraction solves the problem? Now, in 4th grade, you may not have worked with fractions like this yet, but does anything up there look familiar to you? And it's all right if you go, no, I haven't seen that yet, right? Because you may not have yet. So the first part says 10 over 3. That means 10 thirds. Okay, and we're going to add something to that to get 7. Make sense so far? All right. So the fraction bar, 10 in that bar means divided by. So that first part actually means 10 divided by 3. Okay? So here's the way I want you to think about it. If we look at A, B, and C, the options down there, they all have 3 at the bottom in the denominator, that's called.
Yeah.
So more than likely, the answer is going to have a 3 in the denominator at the bottom. So you want to think about something. Do you feel pretty comfortable with your multiplication and times tables? Okay. So we want to get to the answer of 7. And we know we're going to have to divide something by 3 to get 7. So what can I divide by 3 to get 7? And sometimes if you go backwards, like 7 times 3 is something, that might give you the answer
21.
also. Okay, so how'd you figure that out?
I did 7 times 3.
Okay, you did 7 times 3, you got 21, right? So we know that we need 21 over 3, because that means 21 divided by 3. Good so far?
Yeah.
So we know we need 21 over 3. Right now we have 10 over 3. So how many more do we need if we have 10 and we need 21?
11.
We need 11 more, right? But we want to make sure that the bottom number, the denominator, stays the same. Because if we have 10 thirds and 11 thirds, that would make 21 thirds. Does that make sense?
Yeah.
Okay. And we're going to do a little bit more with fractions today, but as long as you're getting it so far. So you know that we need 21 thirds. Because a long time ago, they would write 10 and they would actually spell out divided by 3. And people got lazy after a while. And they go, I don't want to write 10 divided by 3. And they just started putting like the squiggly line, meaning divided by. And then eventually it just became a straight line. So that's how you can tell that that line means divided by. So let's take a look at it. We have 10 thirds, and you said that we need 11 thirds to make 21 thirds. So which one of those answers do you think would be the best one?
I think A would be the best one.
So you think A would be the best one. Now I said we need 21 thirds. Why not B?
Because I thought that you had to add it all together.
Very good, right? That's what I wanted to see if I could catch you right there or not, but you caught me, right? So 21 thirds is what we want as the final answer, but in order to get there, we only need 11 more. So you feeling good about A?
Yeah.
All right, let's take a look and see if indeed A is correct. All right, there you go. First problem, well done. Not too bad, was it?
Yeah.
That's your first fraction problem ever, correct?
Yeah, I was.
All right, good. Well, you know what? It's not going to be your last one. I can guarantee you that. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, so today's Math in the News has to deal with Venn diagrams, but Venn diagrams in space. So as soon as I saw this article, I knew immediately we had to have it on Do the Math, because a lot of you may know the mathematician John Venn already, but some of you may not, but you will later on this afternoon. So let's take a look at an odd radio circle. So an odd radio circle is made of vast rings of magnetized plasma, only visible through radio wavelengths. Now, this is what is cool about this, because you don't see these things all the time, and you've got to be able to see with telescopes to find these radio circles. So here's a photo of it, and these are magnetized plasma rings, but the way they are formed became a Venn diagram. So that's how this all ties into the Math in the News today. So a Venn diagram is where you've got a couple of things and then you see how they relate together. So we'll go to the next slide, and it's to show relationships. So if we said there are a lot of people that love cats, and there are a lot of people that love dogs, but there are a lot of people that like cats and dogs. So they would fit into both categories, and that is the overlapping part of the Venn diagram. Here we only have 2 circles to make up the Venn diagram. A lot of times you'll see 3. You can have as many circles as you want, as long as you have that intersecting part to show the commonality between the different categories that you're talking about. So, Devin, do you like cats or dogs?
Well, we have adopted several dogs over the course of the last few years.
So you'd be a dog person?
Absolutely.
Isabella, cats or dogs or both?
Dogs.
Dogs. All right. Well, then, you know what? I would prefer a dog over a cat, too, so we would have nobody on the cat side right now. I'm sure if I asked a bunch of the other people in the studio, I'm sure they'd get cats, but could be a clean sweep today. Anyway, let's see. Let's see how we can do here with our own Venn diagram. So, Isabella, come on over here, and I'm going to have you help me out real quick. So, go ahead and grab that marker for me, please. And you know the difference between even and odd numbers? Mm-hmm. Can you tell me the difference?
Well, even numbers has 2, 4, 6, 8, and 10, and odd numbers has 1, 3, 5, 7, and 11.
And 9.
Oh, yeah.
Right, okay. So let's take a look. So we want odd natural numbers from 1 to 20, and we want multiples of 3 between 1 and 20. So a multiple of 3 would be, do you know what multiples are?
Oh.
So if I went 3, that would be 3 times 1. What's 3 times 2?
3 times 2 is 2. 3 times 2 is 6.
There you go. And 3 times 3?
Is 9.
So those are multiples, right? If I just count by 3s, 3, 6, 9, 12, like that, right? So what are some multiples of 3? Go ahead and start writing them down in this part of the circle. Right, that's the first one. 3, 6, 9, 12, 15, 18. Now hold on there, sister, because we only have to go up to 20. Are there any more in there, or do we have them all?
That's it.
That's it, all right? So now odd numbers from 1 to 20. So I'll fill this in, and you help me out if I miss any, all right? So I'm going to go 1, 3, 5, 7, 9, 11, 13, 17, 19. I get them all? So I'm going to skip every one, right? Every other one. 1, 3, 5, 7, 9, 11, 13, 17, 19.
You forgot 15.
I forgot 15?
Mm-hmm.
You sure 15 belongs in there?
Yeah.
All right, I'll go with you. All right, 15. Now, we need odd natural numbers that are multiples of 3 and between 1 and 20. So we're looking for numbers that are common between these two parts to put in the middle. So this is a longer list, don't you think? So we'll start with this one. Is 1 in both of these categories?
No.
No, so we're going to leave it right there. What about 3?
Yes.
Okay, so why don't you put 3 in the middle, and I'm going to erase 3 here. Whoop. And can you erase 3 there?
Oh.
Yeah, use your, there you go. All right, so let's go next. 5, do we have 5 in both of these?
No.
No, what about 7?
No.
9? All right, so put 9 in the middle because it satisfies both of these. I'm going to erase my 9. Try it again. There you go. All right, what about 11?
No.
No. 13?
No.
No. 15? All right, so you can put 15 in there. I'll get rid of my 15, you get rid of your 15. All right, and what we're gonna do is we're just gonna make those bigger, right? What was that, 12? Okay, so 17, do you have 17?
No.
What about 19?
No.
All right, so do you think we've got them all? So take a look. These are odd numbers from 1 to 20. These are multiples of 3 between 1 and 20, but these are both odd and multiples of 3. That's how a Venn diagram works. Sound pretty good? All right, there you go. Nice work on the Venn diagram. We'll be back with more right after this. All right, our next mathematician, a British guy, John Venn. And a lot of you have probably heard of Venn diagrams. Venn diagrams are something that you can use when you start school, even in TK, to make complex problems a little bit simpler. So let's take a look at some of the Venn diagrams right now and see if we can organize all of this information. So it says 56 people played basketball. Now we can see there's basketball and soccer, but there's this intersection between basketball and soccer. So we've got 56 that can play basketball. 24 played both basketball and soccer. So in between here, we have basketball and soccer. We know that was 24. Now we know that 56 played basketball, but if 24 played both, we simply take 56 minus 24, we can get 32 right there. 68 players played soccer. So we know that 68 played soccer altogether, but 24 of them played basketball along with soccer. So we're going to take 68 minus 24, which is then going to be 44. And the question says, how many played basketball only? 32. How many played soccer only? 44. Now we have one, it's a little bit longer. So we have 30 students sing in the choir. Well, we have, all right, so we can just put 30 up here because they sing in the choir. But there's kids that are going to be in the choir and they could be in orchestra. And there's kids that could be in the choir and in band. And there's kids that could be in the choir, orchestra, and band, which is that central part right there. So when you have a lot of information like this, one of the strategies is to work backwards. So let's take a look and see if working backwards helps with this one. So 5 students belong to all 3 groups. All right, well, here we go. We can put 5 right in there because they belong to all 3 groups. 14 belong to choir and band. So choir and band must go right here, okay? But it has to equal 14 because of this. So if there's already 5 in there, we know that we need 9 more. So the 9 and the 5 is going to give us the 14 that comprise choir and band. 10 belong to orchestra and band. Well, we're going to do the same thing. Orchestra and band are these 2 circles. We already have 5. We know that we need 10, so that is going to be 5 right in the middle there. 15 belong to choir and orchestra. All right? Well, choir and orchestra are these 2 circles. We know we've already got 5 in there, so we need 10 more. 50 students march in the band. Okay, so now we've got 50 students march in the band. Now, if we have these 10 and 9 is 19, we have 19 kids in the band already, but we need 50. So 50 minus this 19 is going to give us 31. 40 students played in the orchestra. Well, the orchestra is this entire circle right here. We know that we need 40, and there's already 20 kids in the orchestra, so we need 20 more for that. We go back, 30 students sing in the choir, so we can see that we have 15 there, plus 9 makes 24, so that we can see that there are 6 kids in the choir all by itself. How many students will need seats on the bus? Add them all up. There you go. That's John Venn, our mathematician of the day.
Did you know that in a 3x3x3 Rubik's Cube, there are, well, let's just say a lot of different combinations. This means that there are a lot of possible starting combinations that can give you a solved Rubik's Cube. Now you know.
And thanks to Caitlin for that little now you know. Did you know all of that about the Rubik's Cube?
No.
That many different combinations there are? That's a pretty big number, wasn't it?
Yeah.
Well, guess what? Are you a master of the Rubik's Cube already?
Nope.
You might be, because we're going to talk a little bit about that later on, as you are now an ambassador for the program, and you're probably like, I don't even know what you're talking about, but we'll get to that later on. You ready for some more math?
Yeah.
How do you like adding numbers?
I like them pretty much.
Okay, well, you're going to do a lot of them right now, so head on over to the board. So you're going to do a game with Devin called Breaking the Ice. So you're going to roll a die, just one die, 9 times. Every time you roll it, you're going to put the number that comes up in one of the 9 squares. But you cannot go over 999. Otherwise, you break the ice. So you have to think about where you're putting these numbers, because you cannot go over 999 altogether. So as soon as you're ready, I think all you have to do is just hit roll. Where it says roll, you can use your finger on that.
Now, before you do that, I want to ask you about what you know about one single die. So when you roll it, what numbers are on that die? So what are the possible things you could roll?
Like 6,
6 is 1. Okay. What else could you roll?
8,
Well, we only have one cube here, right? So if we only have one that we're rolling, what are the possible outcomes?
2,
So we could have 2, we could have 3, we could have 4, 5, 6, we could roll 1, right? Can we roll a 0? No, there's no 0 on a die, right? Can we roll anything higher than a 6?
no.
No. So there's only going to be those 6 outcomes every time we roll, okay? Keeping in mind, with place value, we cannot go over 999. All right, go ahead and tap the roll button with your finger, and let's see what our first roll is. We have a 3. So where would you like to put this first 3? We can put it in the hundreds column, the tens column, and the ones column. Where would you like to put that? All right, we're going to start off with a 3 in our top in the hundreds place. All right, 8 rolls to go. Let's go ahead and roll again. Oh, ones. Ones are great to have here, because remember, we want to go, as high as we can, but we don't want to go over. So where do you think you'd want to put that 1?
In the ones place?
It's up to you. Go ahead. All right, so with our first 3-digit, we have 300 and something 1. Let's go ahead and roll again. Oh, great, another 1. Okay, where do we want to put that?
I want to finish the top row.
311. Shout out to my 90s people there, you know it. Let's go ahead and let's roll again. Okay, we have a 4 now. Now, we can get close to 999, but we don't want to go over. So where would you like to put that 4?
Maybe in the ones place.
All right, we're going to go ahead and bring that 4 into our second ones place value. Let's roll again. We've got 5 more to remaining. That's a 5. That's a big 5. Where could we put that 5?
Right here.
All right, we're bringing that into that tens place. We're keeping the hundreds open. What numbers are you really looking for, I think, ideally for the hundreds place? What are you hoping to roll to put in the hundreds?
Maybe a 2.
A 2. Why do you say a 2?
Because if I get a 2, I can get 5 for that.
Okay, so you want to get kind of close to that halfway point here. Okay, let's go ahead and roll. Oh, we didn't get a 2, but we did get a 3. Where would you like to put that 3?
Right here.
Okay, we're going to bring it. Now, we are out of ones places. We have 3 rolls left. We have 2 in the hundreds and 1 in the tens. Let's go ahead and roll. There's your 2. You landed on it. You know where you want to put it. Go ahead and make it happen. All right. We have 2 rolls left. Without knowing what we could roll, what do you estimate we're at right now? Or where are you about? About how much do you think you already have at this point?
567.
I think we have exactly 567. So knowing that, we want to get close to 99. We don't want to go over. So these next 2 rolls are going to determine where we go on that. Oh, that's a 4. Okay. Now you got a tough decision to make here. If you put the 4 here, that brings you into those 900s and gets you really close. You said we had 568. That would put us to 968. But too high of a roll might bring us over 999. You want to take the risk? Or you want to see if you get something a little lower to play it safe? I think you're kind of playing the same kind of risk no matter where you put it. So where would you like to play the 4?
Right here.
Okay, we're going to put it in the tens
Yeah,
place.
there we go.
Okay.
Always risking. Could be a 5 or 6.
5 or 6 puts you over. I think even a
Let's
4
see.
might, though. Let's
Right,
see what
let's
happens
see.
here, okay? One final roll. Ooh, the 4. Okay, let's go ahead and see how close we got to 999. Did we go over or did we get close? We have 311 plus 254 plus 443.
Oh, add them up.
Start with
This
the
turns
ones.
into a 7.
Well, let's make sure we add all this together, right?
Oh.
We have 3 digits in that one, so 4 plus 3 is 7, but we have to include
Oh,
that
yeah.
one at the top there. So that would end up being 1 plus 4 plus 3, which is, you can just go ahead and write on that now, yep. And that is 1 plus 4 plus 3, which equals?
8.
Okay. Nothing to carry over, so we can just add the tens place digits. 1 plus 5 plus 4
Is 9.
plus the
Plus
1.
the 1 is 10.
Great, so we're going to bring a 1 over to the hundreds and then bring that 0 down to the tens. All right, we have 1 plus 2 plus 3 plus 4. What does that get us?
9.
Well, if we add 3 plus 2, that's 5, right? And we add 5 plus 4, that gets us 9. We get 9 plus 1.
It's 10.
Can you look at how close we got there? I'm gritting through my teeth on this because we are just 9.
But you know what I like
over.
about it? I'm going to give her some good credit here because you had to get to 999 and you got 1,008, so you were 9 over, so I'm going to say you kind of did well with that anyway.
Extremely
Sound
well.
pretty good? See how we can work those 9s in there? Anyway, for having a great game right there and taking a nice risk at the end, you've got yourself a pass to any athletic event at CSUB Athletics, so congratulations on that. We'll be back with more right after this.
Hi, I'm Zenaida. Welcome to another session of the Math Framework series. Today we are going to discuss how students learn to compare and order numbers in transitional kindergarten all the way to grade 2. Students in transitional kindergarten through grade 2 develop their understanding of comparing and ordering numbers through extensive counting practice. This practice helps them learn how to locate numbers on a number path and in grade 2 on a number line. One way to help students organize and compare objects is to have them compare quantities. And I have Selena here with me. And so I want you to look, Selena, at this first set of items and this second set of items. And I want you to tell me which set has more.
This one because it's 9 and because look, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so you're saying that this set has more
Yes.
than this set over here.
Yes.
How many are in this set?
6.
Okay, excellent. And we could also play a game. A game that involves comparing different quantities, okay? So this game has 2 cards, and I'm going to show you the 2 cards, and you're going to tell me which one has more.
Okay.
So let me show you these two cards.
So the one with the black dot has more
Okay, and how do you know?
because that one has 3 and this one I see it has more than 3.
Excellent. So we can use visuals to compare quantities, and we can also use the numerals. For example, I have two cards right here. I want you to tell me which one has more.
15
How do you know 15 is more?
because that one has 2 numbers and that one has 1 number.
All right, thank you, Selena. That was wonderful. At first, students compare collections of objects by lining them up and using comparison words, such as more, fewer, same as, and greater than. Eventually, they apply their understandings of place value to compare the number of hundreds, tens, and ones. It is important to provide children with opportunities to explore different quantities and to explore number relationships. This helps them understand the magnitude or the size of numbers. Students who develop a solid understanding of comparing and ordering whole numbers will be able to build on this foundation as they work with fractions, decimals, and larger numbers in later grades. So let's continue to explore problem-solving approaches, fostering flexibility and efficiency in our thinking. Thanks for tuning in and keep doing the math.
That's the key, keep doing the math. And in studio right now, we have David Harrington, who's going to help us do the math. David, how are you today?
I'm excellent. How are you?
Well, now that you're here, and we can talk a little bit about CNS, Center for Neural Skills. And what is your role with CNS?
My role, I have the fortune to be the CEO and president of the company.
So you are the president, man. You are
I
the
am.
man of
I
CNS,
am.
right?
That's right.
All right. Now, CNS is located here in Bakersfield, and you
Yes.
guys are one of our newest sponsors of Do the Math, and we certainly do appreciate your sponsorship of the program. But there's other places that CNS is also. So where else is CNS located at?
Well, first of all, we're honored to be a sponsor, so thanks for letting us be part of this. Well, we're in Bakersfield, Los Angeles, San Francisco, Dallas, Fort Worth, Houston, Austin, and we're opening up a new location in Plano, opening next month.
Okay, so you've got Texas and California,
Yes.
whereas you guys are focusing.
Correct.
So there are people going, all right, you said CNS, Center for Neuroskills. What exactly is CNS? What do you guys do?
Yeah, CNS is a very specialized rehabilitation and medical facility that treats people with brain injury.
Okay, and there are a lot of different types of brain injuries. And I know that on the screen right here, we've got, that's in 1 year, 3.4 million people suffer brain injury?
There's a lot. There's a lot.
Okay, so talk to us a little bit about some of the differences up there.
Yeah, I'll come over here and show everyone. Basically, we break brain injury down into 2 large categories. One would be traumatic brain injury, and that's anything that has an external force, like hitting your head on the wall or getting in a car accident or falling off your scooter. But there's also acquired brain injury, which is a stroke, or if you have a heart attack and you lose oxygen to the brain, you get an anoxic injury, or you can get a virus or bacteria or a tumor, and those things also affect the brain and the brain's health.
Okay, so the big one, that TBI that you were talking about, that's the majority of it.
That's the majority of it.
Okay,
That's correct.
so when somebody suffers a brain injury, whether it's through a fall, an accident, or something other than that, there are different parts of the brains that are affected, right?
That's correct.
So let's take a
That's
look
correct.
at the brain.
Yeah, so this is a really nice map here, and so you see the outside of the brain, there's a lot of structures that are inside the brain. The frontal lobe is our executive function. This is where we do our problem solving. It holds our personality, our judgment. And then we have the parietal lobe up here that when you touch your skin, that's where you feel it in your brain.
Okay.
But it's also your spatial map, your distance from you and the wall and the table. Then we have the occipital lobe. This is our visual cortex. So the eye then brings the information back to the occipital lobe to begin to process that information. The cerebellum has to do with your balance and your movement and your coordination. And down here at the brainstem, this is all your very primitive work, like your breathing, your heart rate, all of those really important vital functions.
Involuntary actions are going to be through there.
Exactly.
Now, the cerebellum you just said, that's the one with balance and things. And if I'm not mistaken, falls and things like that are a big reason for brain injuries.
Yes.
So because the cerebellum is affected in some way before a fall, because that would kind of affect if a person did fall. Does that make sense?
It does make sense, yeah. Gravity is not always our friend, right? And sometimes it's momentum where we lose the coordination, we fall off our scooter. It doesn't necessarily mean that you have a problem with your cerebellum, but you have to, in order to maintain balance, you need your visual system, you need your vestibular system, which is in your ear, and your cerebellum, knowing where your body is positioned. And those three systems have to work as a team in order for you to keep balance.
Okay, so it's not just that one part.
It is.
They're all working together.
Exactly.
Okay. And I know it's not up there, and I know we're going into the traumatic brain injury part, but I'm going to go off track here for a second.
Of course, yes.
So people go, I'm left-brained or right-brained.
Yes.
So it's kind of a creative side and more of a thinking side. Is that fair to say?
Yeah,
to
that's very
break
fair.
it down pretty easily?
Yes. Yeah. So we're all different and we're all wired differently. And some of us are very analytical. We love the math. We love the engineering. But some of us are very creative, more the right brain where you paint and you construct and you can design. You can visualize things in your mind and then create it. So we're all different, but we all have a little combination of both.
Right. So looking at the frontal lobe, for example, somebody gets hit, and so would it matter if it affected one side of the brain or the other where that injury happened?
It really does. And a lot of times in neuro rehab, we really need to look at where that person is injured, because then that will begin to reveal the problems that we need to fix.
Okay.
So if it's the frontal lobe, it's going to be a lot of personality, it's going to be a lot of judgment, problem solving, versus the occipital lobe, that person's going to have a lot of visual processing problems. So we're going to have a lot of visual problems. And quite frankly, when you hit something, your brain jostles around. So even if you hit the front of your head and your frontal lobe, your brain bounces around, and it can also affect the back of your head and the back of your brain.
Which will bring us into the traumatic brain injuries, where we're talking about the falls, accidents, things like that. And then you are showing us, we got a little bit of math in here with the percents.
We got a lot, everything's math that we do in healthcare.
That's right.
This is a relevant topic. Yeah, most of us are falls, and it really is age dependent. When we're little kiddos, I remember my son taking off running and he dove into the couch, but he missed the couch, right? Kids fall a lot. But
Right.
also when we get older, we lose our balance, we lose our vision, and it becomes more difficult. So falls in that later part of life are highly likely. Versus motor vehicle accidents, when you're learning how to drive, that's when you're most prone to get into that motor vehicle accident. So sometimes these statistics change depending on the age.
Okay. And I know that there's a scoring system that you guys use, but before we get to that, let's talk a little bit about the different things that could affect inside the brain, how these things happen. So we'll take a look at
Yeah,
this.
so this is a really great illustration. So not everything is an external force like hitting your head on something, but sometimes for some reason we have problems in our blood vessels within our brain. And what you see here is this ischemic stroke. This is where for some reason someone may have a clot. Maybe it's formed in their leg and it's going through the circulatory system. Sometimes it lodges in the lungs, but sometimes it goes up to the brain. And unfortunately, it's like a dammed river where it just doesn't let the blood flow to where it needs to go.
Okay.
And those areas that are associated that begin to die off or become damaged. But we can also have a hemorrhagic stroke. This is kind of like a blood vessel bursts. And so not only then you lose the blood vessel there, but also the blood that is leaking out can also impair the brain. And then a little transient ischemic stroke, these are like mini strokes, where you may have stroke symptoms for a short period of time. The symptoms go away after a short period of time as well. So.
But it's still having a lasting effect on the brain.
It sure does. And once those neurons die off, then that's when we come in and we essentially have to rewire the brain to get people to think better, to walk better, to process information.
Okay, because we talk to the students a lot, and we're actually going to be doing it later today, struggling where those synapses are going, and you're building things in your brain, and it's actually getting bigger and working and doing that type of thing. But the strokes and things like that, that's where somebody goes, well, I'm very careful and try to take care of themselves, but some things could just be genetic also, where
Exactly.
this is going to happen regardless.
Correct.
And that's part of brain injuries also.
It is.
But once somebody has a brain injury and they're at CNS, there's a tracking system, kind of watch their progress so that they can become more independent after having services with you guys. So I know that we've got a beautiful graph now with all the numbers
I
on
love
it.
data, and this makes my socks roll up and down. I love this, right?
There you go. So the one thing I do want to talk to you about, I'll let you go through it, but I want to know why there's such a jump between that red and green, because it's not like a 1 or 2 or 5. It's quite a bit of difference between those.
Yeah, over here on the right-hand side, and I'll kind of walk through it a little bit. So this is an actual patient that we had at one point. And when a person comes into Center for Neuroskills, we do a lot of assessments and we do a lot of math. We figure out how they're processing information, how they're walking. But what this helps us to do is to pull that all together to look at how someone is doing with their activities of daily living. Can they dress themselves? Can they cook? Can they do laundry? Can they go grocery shopping? But we also look at their initiation. Do they start the activities? Maybe they know how to cook, they just don't know how to start the activity. Okay. And then the behavior, whether they have angry language or refusal to do things or they exit a room. So we compile these 3 scores into one overall independent living scale score that's over here on the right. And what you see here is this patient, week over week, began to improve. But you're right, at this point, there was a big jump in that patient's program. Maybe everything began to click for that person, okay. Right? And the reason why it turns from red to green, it means that this person is more independent. Now we have to refine the skills. Now I would say for this particular person, they needed to stay in our inpatient program. They need a lot of care. But once they got up here into the green, they needed far less care and they're almost ready to go home.
All right. Well, that's a lot of great information. Come on over again here, David. And we certainly do appreciate CNS as a sponsor of the program. I know that we're going to be doing a lot more things with you guys throughout the year.
Looking forward to it.
And you're a pretty busy guy overseeing quite a few different properties of CNS throughout a couple of states. So we certainly do appreciate you taking out some time to come visit us.
Thank you.
We'll be back with more right after this.
What are Lagrange points? Lagrange points, named after the Italian astronomer who first proposed them, are places in our solar system where the gravitational pull of the planet and the sun and the motion of the orbit combine to create an equilibrium. So it takes very little energy to retain that orbit. Objects that are sent to these locations in space either tend to stay there naturally or can be kept there with minimal energy because the forces are in balance. NASA's taken advantage of those Lagrange points to send extraordinary missions like the James Webb Space Telescope, which will orbit the Sun at Earth Lagrange point number 2, allowing the telescope to stay in line with Earth as it moves around the Sun and retain that orbit using very little fuel. NASA's Lucy mission will study the pristine Trojan asteroids, the remnants of our solar system that have been gravitationally trapped around Jupiter's Lagrange point number 4 and Lagrange point number 5 for over 4.5 billion years. So what are Lagrange points? They are places in our solar system where objects can orbit the Sun at the same speed as a planet, staying in the same place relative to both of them.
All right, we have Isabella, a 4th grade student from Reagan Elementary, in studio with us, and you are ready to do a little struggling?
Yeah.
Yeah, all right. Well, it's always good to struggle because, as we were just talking with David, the more you struggle, your brain actually grows every time you struggle to learn something. So you're going to play a game that is provided to us through Struggly, and today you're going to be finding fourths. So you're going to work with more fractions. You ready? Mm-hmm. All right, head on over to the board, you and Devin. There are no directions. It just simply says color the shape to match the fraction. So you need 1/4 being pink, and the others will be blue. So both of you work on this, and then I think what you can do is just use your finger to move that blue square up there and move it down into the grid.
So you can move the square with the finger into somewhere in the grid so that it fills in that space. Now, we're looking for 1/4 of this grid to be filled in as pink and then the rest to be blue. So I wonder if there's anything else we can do other than just drag the shape in there. So let's see what happens when we do that. Go ahead and try it out and see what we can do. All right, so we have it kind of in there. Now, if we think about 1/4 of this shape, right? And we have this main grid broken up into 16 squares. How many of those squares do you think would be equivalent to 1/4? Or rather, could we break this into 4 equal parts?
Yes.
So how many squares would be in each part?
4.
4, okay. So we're looking for something that's going to fill the same amount of space as 4 of these smaller squares.
And Devin, I think when you move the blue square over, there are some circles on your side where you can,
Oh, look at this.
right, so you
We
can
have some
maneuver it a little
rotations.
bit to make it fit.
So we can rotate it, we can shrink it, we can stretch it. What would you
And
like
you've
to
got
do with
about
that?
2 minutes, so you
Oh.
can probably start maneuvering
All right,
that.
well, we can kind of rotate that. And if we do that, can we move it somewhere to cover 1/4 of those squares? Mm-hmm. Try it. Let's see.
Right here?
Okay. All right. Oh, and look what happened. It gave us a pink rectangle up there. All right. Well, let's go ahead and bring that down. Is there somewhere on this square, because it looks like we have to fill in 1/4 of this pink, and we have this pink rectangle that we can bring in there now. So can we put that somewhere to help us cover some of that inner grid?
Right here?
Let's try it. Oh, we have another pink one up there. Let's see what we can do with that.
Put it right here?
Let's go ahead and do it. Oh, okay, so now we have another pink rectangle, but it looks like we may have to rotate it. Which way do you think we should rotate it? To the right or to the left?
To the right?
Let's rotate it to the right. Oh, wait a minute. Let's go ahead and select it then. And let's rotate it to the right. Now that makes it kind of a vertical rectangle. Is there anywhere we can put it here on the grid to help us out? All right. Oh, there's another pink one right over
Just
there.
out of curiosity, Devin, hit the blue button and see if it turns that blue up. Okay, so the one that was just placed, it does. Because remember, you want 1/4 of them pink. So you can alter the colors if you need to.
So let's go ahead and take that other rectangle that we had then. Do you want to keep that pink, or should we change it to blue?
I don't know.
Well, what could we try?
Put it right
All
here.
right, let's go ahead and bring it right there. All right, we have another rectangle up there. Can we, oh, we can change it once we select it from pink to blue. Did you want to keep this one pink? Mm-hmm. Okay, and now we have another one that's kind of tilted. Do we want to rotate that
Yeah,
to the left or to the right?
to the right.
To the right, okay. It's vertical again for us. Now, do we want to keep that pink or do we want to change it blue?
Blue?
All right, let's change it blue. I feel like we're getting close here. We have one more rectangle up there. Do we want to rotate it? Do we want to try to drop it down? Do we need to move anything? What could we do here?
Rotate it.
Okay, to the right?
Yeah.
Maybe a little bit more? Okay. Now, we need to fill 1/4 of this pink. And remember, we said 1/4 is about 4 of those smaller squares. I think we have a little bit more than 1/4 because I think 6 out of those 16 are filled in pink right now. So is there any way we can change 2 of these pink squares into blue squares?
I don't know.
Well, can we select any of them and change them to blue?
Yeah.
Okay, which one would you like to change of those pink rectangles that are up there?
This one?
Well, this is already blue, so which one do we want to change pink? You decide. You can tap any of those pink rectangles, and then we'll see about changing them blue. All right, let's go ahead and tap blue here. And there's a little change here. It says to tessellate. So I wonder if that's a button we can push or if we have to change something else here. Go ahead and push that, and let's see what we can do. Oh, it created a tessellation for us, a pattern of that shape across infinity in all directions. You can zoom that out, and it'll keep making that pattern forever and ever. We made a tessellation. I didn't know that was the grand prize for
Nicely
that.
done. Pretty cool. huh?
Oh,
All right, come on over here, you guys.
go right ahead.
So that was pretty good where you make that tessellate and then you can alter the size of it and things later on. So as you get into 5th and 6th grade, you're going to do fractions where you won't even be able to count how many different fraction problems you're going to be able to do. And then when you learn about tessellations, which is what that was, you're going to have a lot of fun because then you can implement a little bit of art with your mathematics at the same time. But I remember earlier you said that you were pretty good at long division right now, right? So can you share a problem with us?
Yeah.
All right, head on over to the board. And I know that you've got one on your homework here, so I'm just going to read this problem, and then you show Devin how to solve this. All right, so I'm going to have Devin write any information that we think we're going to need. So it said there are 3 boxes of tangerines.
3 boxes of tangerines.
Each box has 93.
and each box has 93 tangerines.
They need to be divided equally among 9 classrooms.
Divided among 9 classrooms.
How many will go to every classroom?
All right, and each room gets how many? And that's what we're looking to find, right? So let's talk about what we can do with this information. Where would you like to start to solve this problem?
3 times 9?
Well, why 3 times 9? I know we have 9 rooms, and we have 3 boxes of tangerines. We're ultimately figuring out how many tangerines each class gets, right? Mm-hmm. So I think we have to figure out how many tangerines we have altogether, right? So we have 3 boxes of tangerines. So we have 3 boxes. How many tangerines are in each box?
93.
93. Okay. So that means this represents the total number of tangerines we have. Mm-hmm. So how can we calculate that pretty quickly?
We divide that?
Well, we have each of these with 93 in each. And we know that there's 3. So is dividing the way to go on this one?
No.
No, we probably want to multiply in order to figure out how much we have altogether. So what would we multiply?
93 times 3.
All right, let's go ahead and multiply 93 times 3.
So 3 times 3 is 9.
Okay.
And 9 times 3 is 27.
All right, so that means we have 279 tangerines altogether. It's a lot of tangerines. It's a good thing we have 9 rooms that we're going to split them up among. So if we have 279 tangerines, but we have 9 rooms, what do we do to figure out how many tangerines each one gets?
We divide.
Now is the time for us to divide. So let's go ahead and divide. If you want to kind of clear out some of the space here, or maybe even work up top here, like you've got some space. Let's go ahead, and we have 279 tangerines. I remembered that number, so let's start off with 279. Okay, we're going to bring in our long division bracket, help us out here. And now we're going to divide this by 9. Okay, so show us how you would divide that and explain each step of the way.
Well, 9 can't go into 2, so you put an X over that. So you would do 9 times what could equal 27 or is close to 27.
Okay.
So 9 times 3 is 27.
Now, just for clarity, for those that are learning about division, that X doesn't mean like we're done, it's over, it's wrong. What is that X for?
For times.
Well, are we, okay, so you're using it as a way to kind of make sure you're reminding yourself that these two should multiply close to that. Okay, go ahead, continue.
Then you subtract these 2 numbers from each other, and then 27 minus 27 is 0. Then after that, you take down the 9 and bring it down next to your number right here.
Okay.
So 9 times what could equal 9? 9 times what could equal 9 is 1.
Great. And then we're going to check to see that 9 minus 9 is something
0
to work with. And so there's none left over. We don't have to split any tangerines into smaller parts. There's no remainders. We have a nice whole number we can divide among the 9 classrooms. So each room is going to get how many tangerines?
31.
31. Now, if we wanted to check and make sure, we could multiply 31 times 9 and make sure we get 279, but it looks like we have our solution. Each room is going to get 31 tangerines. Wonderful work with the division on that one.
Nice to see that Isabella went ahead and checked that problem also. The only thing that wouldn't work with that is if you had 32 kids. Or 31 kids and the old man in the room. I need a tangerine too.
Just one though, right?
You feel pretty good about that problem though, right? Mm-hmm. You did a nice job on that.
Thank
We're going to
you.
be back with more right after this.
Space weather starts with the sun. The sun is always emitting material, solar wind, plasmas, and it sets it off throughout the solar system, and that's sort of the background for space weather. But we get things like storms. Coronal mass ejections are big solar eruptions, and they have lots of material and lots of electromagnetic field, and those things propagate throughout the solar system.
We hear about magnetic fields with the sun.
Yes.
What are solar magnetic fields?
Okay, what are solar magnetic fields? Well, we're going to get into the basics of plasma physics with this. So, plasmas are collections of charged particles. So they're electrically charged particles. And when they move, they create magnetic fields. And the sun is made up of different types of plasma. It's real complicated on the sun because we have small-scale magnetic fields and then we have very, very large magnetic fields. So I think everybody or most people are familiar with the idea of a magnetic field from a bar magnet. In quiet times, at solar minimum, the sun is essentially a bar magnet. The magnetic field is kind of like this. But because it's not a solid body, it's not made of a solid material, it's made of this plasma, right? It's twisting and moving, and so the magnetic fields get all sorts of twisted up, which is what gives us things like sunspots and coronal mass ejections.
Why is it important to understand this?
It's really important to understand it a lot today, like in today's society, because we have so much that depends on electricity. Our electrical grids, our satellites, our communication satellites, all of these things can be impacted by these big solar eruptions because they are electromagnetic storms, essentially. So when you get buffeted by something like a coronal mass ejection, it can cause charging on your satellites, it can disrupt them, it can cause large electrical currents to run through our power grids and potentially be destructive there as well. Solar eclipse is an amazing time to study the sun because we are positioned sort of perfectly, and the moon is positioned perfectly to block out the very bright disk of the sun so that you can see the corona, which is the solar atmosphere. It's very diffuse, and the moon is positioned perfectly just to block out the surface of the disk and nothing else. And so there's nothing else that's made by humans that allows us to see very, very low in the corona.
Why is it difficult to see the corona during normal conditions?
The surface of the sun is so bright, right? When you look up in the sky, you just see this bright ball. And so it's so bright that you can't see what's happening in the atmosphere, in the corona. So under normal conditions, you won't really be able to see the corona. You have to have something blocking out the surface. A sunspot is really cool because they are actually visible. If you have appropriate viewing glasses, you can actually see a sunspot. So they're dark spots on the surface of the sun that are regions of high magnetic field, so very, very concentrated magnetic field that gets super, super twisted up, and they can grow, they can change their shape, they can shrink. A solar flare is another type of solar eruptive phenomena. So a solar flare is a very bright flash of light that has very, very fast particles. It energizes sort of small amounts of particles to be almost the speed of light. So it's different from a coronal mass ejection, which is a very large eruption of billions of tons of material. Solar flare is most noticeable because it does a very flashy thing. Solar flares are also disruptive. Yeah, they can be. The particles, when they hit Earth's upper atmosphere, can cause the atmosphere to sort of to grow a bit. And because the particles are so energetic, when those things hit satellites, they can be disruptive to satellites, cause charging on the surface. So understanding the solar environment, the atmosphere, the background, what's happening there, and then when you have storms erupt is really important for monitoring these systems because these systems can be so disrupted. So it's a lot of stuff that we don't necessarily see on a day-to-day basis, but is important to understand in the long run.
What is the most exciting thing for you about space weather?
The most exciting thing for me about space weather is the day-to-day changes. It's really cool to be able to look at the sun and track a sunspot that you see growing or changing in complexity and try to guess if it's going to erupt. And this is something anybody can do. You don't have to be a scientist to be able to do this. I really like monitoring features like filaments, which are these long magnetic structures that can grow on the sun and they can erupt too. So it's fun. It's fun because it's dynamic. On a day-to-day basis, it's fun because it's always changing.
All right, in studio we have Isabella, a 4th grade student from Reagan, and you have been doing quite a bit of work today. So I do have to say that was some excellent work with the long division.
Thank you.
And you have done a little bit of work with fractions, because fractions is kind of our theme for the day, because at the very beginning we had to figure out how many thirds would make 7, and we knew it was 21 divided by 3, right? And then you were doing fourths with the Struggly game, right? And you and Devin figured that out, where you figured out 4 of the squares out of the 16 would be 1/4. So you're going to do some more with fractions, but we're going to go all the way back to the very beginning right now. So this is going to be some stuff that you might do during 4th grade this year, but you definitely will do it next year. So we'll get you a little head start on that. Sound good? All right. Head on over to the board with Devin.
All right. There's a couple of different ways to look at fractions. We've done a lot of work with an area model where we fill in a shape and break it into smaller parts. But there's a lot of different ways that we can also look at it in terms of division and a comparison of a part to a whole. If I was to draw 3 circles, how many circles did I draw?
3.
3. Okay, so that represents the number of objects I have in this set. Could you go ahead and write a number 3 over on your side? All right. Now, out of those 3, how many of them are colored red?
1.
Let's see, how many of these are colored red? How many of these are red circles?
Wait. 2.
We have 2. Great. Could you do me a favor? On top of the 3, could you write the number 2? Now, interestingly enough, what you did was you wrote this as kind of a comparison of the red circles to the total number of circles altogether. If we were to take the total number of circles as one whole set and divide this one whole set by the number of circles we have so that each is its own circle, we're dividing that one whole into 3 equal parts. Or we would call these thirds. Now, how many of the thirds are colored red? 2 of them. If we take the entirety of the set and talk about how much of it is filled with red circles, we would say 2/3 of that set. So one way we can think about fractions is as a set. There's another way we can think about it in terms of a length as well. If I was going to, let's say, have a distance I was going to drive, I'm going to start here and I'm going to end here. But it's a long drive. And I want to split this into, let's say, 2 days, where I drive the same amount the first day as I would the second day. Where do you think I would stop on that line?
Right.
Kind of in the middle, right?
Yeah.
Okay. Wherever that exact middle would be. Now let's think of this as if it was one whole. If we split this into 2 parts, how far would we have gone if we are just done 1 out of the 2 days? Right there, which is 1/2. So there are a lot of different ways we can think of fractions: as a set, as a length, as an area, and as a comparison, a ratio.
There you go.
between 2 numbers.
Nicely done. Come on over, Isabella. So I've got 2 questions for you. Did you learn a little bit of something today? You learned quite a bit, I think, today also, right? So you're now an ambassador, so you need to tell other people about the show. Can you do that? Good. Did you have fun today?
Yep.
That's the most important thing right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.